So, guys, I'm very sorry. So our head, of the seminars sent with the crashed notebook. So I will share with it. I will share the screen, and I think you can see the problem. I just tried to solve it, but it doesn't. So I don't know how to make the training loop. And how can I just show you the training epochs? So, but by the way, let's do it in a short seminar, the last seminar. Oh, well, so today there is a seminar, the last, and so I wanted to show you the fine-tuning sentence transformer for the text matching. So I wanted to use Jina embeddings model and the STS benchmark dataset. So for typically it's okay for these credentials. I will delete it. It's only for this seminar. So the trained model is neural networks that have been trained on some massive amounts of the text data before being adapted to specific tasks. For example, like for our task. So and they capture general language understanding that can be transferred to downstream applications. Well, so pre-training is the process. For first of all, we have the self-supervised learning. So models learn by predicting some masked words or next sentences, for example. Yes. Then and we have massive data sets. So some typically it's billion that are billions of words from diverse sources. For example, GitHub, Archive, etc. So and transformer architecture. So typically we use attention mechanism. So self-attention to understand context, but it can be cross attention, something in other attentions, for example, like infinite attention, etc. So and such pre-trained models, of course, have their benefits. For example, transfer learning capabilities. It's great for vision models. For example, we can trained some vision transformer, and then we can just fine-tune it or use in a few shot, like in an inference, just as an inference to some another tasks. So, for example, Quen visual language model Quen typically used in some applications in self-driving cars for bounding boxes or capturing bounding boxes. So for labeling bounding boxes. So and it's great tool for such tasks. And of course, these so one of the benefits it's a reduced need for task-specific data. So we got the state-of-the-art performance across like NLP tasks or CV tasks, yes, and of course we have efficient feature extraction. So what about that sets? So we can, I think it's great to change my kernel. For example, we can make T4 GPU. So and okay. Well, let's try to install some dependencies which we really need for the set. So about the tab STS the multi machine translation dataset. So I will show you. Okay, it's here. Yeah. So, uh, well, we use this dataset, so semantic textual similarity benchmark. It contains sentence pairs in multiple language. For example, we will use English, but here you can see, so here's Deutsch, for example, yes, German language. So human annotated similarity scores from 0 to 5. For example, if you can see this sentence and this sentence, so then the human labeled, oh, I'm sorry. Oh, okay, human labeled that it's the score 2.5. Well, and here we have the 0.5 score. For these two, I think the same equal sentence. Yes, so 5 is the equal sentence, and the last numbers is not equal. So like this and this. So yeah, that's it. So it's designed for evaluating semantic similarity models. For example, to so to match the positive pairs and negative pairs, for example. So here we have, of course, thousands of the sentence pairs, and of course we have to balance across different similarity ranges. So, and we use these that set first of all for filtering pairs. We use it for similarity threshold, similarity score. For example, more than 4 similarity score, it's the positive pairs. Then less than 2, it's negative pairs. So yeah, so we installed all our dependencies. Then we can import it. Okay, and here the data. Learn rate. I think it's great to check that we have the device over CUDA kernels. Yeah, it is. So, okay, let's log in for a temporal token. Well, so we want to load our dataset, so in English, and split on train. I really hope that everything will be okay in it, because it's the crashed notebook. I think it's one of the worst notebook. Okay, great. So, as you can see, we have two sentences. So a plane is taken off and an airplane is taken off. And military score is a 5.0, and language is English. Okay. So, and here the sixth, okay, man smoke. Okay. 0.5. Okay, this is the differences in the meaning and the words. Okay, so the positive threshold, as I said, so is 4. The negative threshold is 2. So, and we creating pair examples. So, then, so it's just for understandable for our model. So like positive and negative examples. So, and here we tokenize, here the process of tokenizing, and we tokenizing text for a model expected format, just with attention mask, etc. So here our class of paired datasets. So on the dataset class. So and it's a basic 3 methods. So init, len, and get item. So and here we can use that loader, our data loader. So what about model? What about model? The model it's a Jina, Jina embedding v3. So it's a state-of-the-art multilingual embedding based on LoRa with LoRa task. So it has 8,000 token context length, 8,000 tokens embedding dimensions. So no, 800, 192. So it of course supports for multiple languages. It's vital for us because we, as you can see, we have Deutsch, we have English, I think we have France, etc. So now that's set, but of course I wanted to use only English. So, and this model have an asymmetric architecture. So here it is some different encoders for queries and documents. So as you can see, we can retrieve some LoRa adapters. So, and then we put it in the transformer. So, and here we have a really high dimensional embedding, and it's really great for us because we can capture fine-grained semantic information. So it has efficient attention mechanisms. So we use flash attention for rolling sequences, and flash attention is great for timing. So it's work really fast and have a really nice compute. So, and we have some task specific heads, but it's some details from the paper, from this paper. Well, so of course it has some layer normalization, residual connections, like skip connection, some dense projection or high dimensional space, but otherwise we overall we have great model. So for embedding task, nice. Let's load it. So default task, so to device to CUDA, yes, to our GPU. We loaded it. And I really want to see that. Can you wait? That's all? Oh no. Strange to see 0 in a memory of the GPU, but okay, but it's strange. So because I don't see uh, well, let's check the cosine similarity. So for example, we have some text on the sentences, like positive examples and negative examples. So we can use our model. As you can see, it uh, uh, well, something terrible with triton. Nice. Well, maybe. Uh, well, nice notable. Thanks, teaching office. Everything is okay. So very strange that it's in the master branch in our GitHub, so it doesn't work. So interesting as it can be. Mhm. Okay. Nice. Even this part doesn't run. Cells. Overall, so the idea was to take some positive example and negative examples, two sentences, and then to run it through the model to get the embedding, and then to check the cosine similarity by embedding. So, and print the cosine matrix. So, and to see that, yeah, it's great to see so that first of all we have the great cosine similarity. Yes, and here we have so less, so less, so worse cosine similarity in this matrix by the our sentences. Here I tried to solve the problem of the ply rotary, so but I couldn't. It's done it. So, well, I think we can try to find some another model for embedding. Maybe it's a problem with only with this model. Mhm. Oh, this is okay. We can try it. How much files? Here it is. Oh, not really. Okay, let's try. Nice. So I have no idea how can I fix it now. So uh, so the logic of the following code is about, so we have our pair loss class, so we can use it like here. We have some margin and our function cosine embedding loss. So based on this cosine embedding loss from a neural network from the torch based on margin. So, and then we have some targets, and we just make the cosine loss by the two embeddings from the model. That's all. So we use our atom with learning rate. And so we have our training process of the encoded input, encoded the second input. We have two embeddings. We have our loss values from the loss function. The function is the pair loss. So, and then we use our backward, my step, and that's all. So, and model evaluation. So that's the simple structure that in a relation that loader we have some encoded input, two inputs, then we have two embeddings, then we have our loss, relation loss, that's all. No metric, but we can use the greater or metric, so it's the minimum validation loss which based on cosine similarity in pair loss. So, and so we have some average losses here. I don't exactly know what we have to do to run this code. It's really strange. It's strange for me that that's in a master branch there are code which couldn't run in a collab, even collab, not in the just VNF, not in the local machine server, just in a collab. So I'm very sorry. Mhm. I think this is the last chance to run all cells and to run the dataset and the model processing. So nice. Then we can load the model. Oh, nice. It's my fault. Let's try one more. Wow. Okay. Okay. So we loaded the model, but as you can see, we have some problems with run Triton PTX code gen error. So something strange with the precision format of the model. So okay. So well, the typically task is like this. So it's I can show that it's really the main repo of our course. It's really strange why it's wrong. Okay. Okay. So it's the last seminar. So of of our course. It will be really great to have a feedback, your feedback, based on our seminars, seminar lessons. I'm very sorry for today lesson because it's for me it's default 2, and but it's really hard to don't write the new code and repair the someone's code to make it more optimized or to fix it. It's really bad idea to do it in a seminar. So if you have some questions about fine-tuning models, so I can answer on it. Well, I really recommend you to go to the exam on 7th June because I will be there on 7th June. And so it will be great to test you to see in a offline world. So that's all for today. If you have some questions, but so let's ask.
So what would be the exam format? Is it like theoretical or some implementation based?
It's theoretical, I think, a bit. So based on my experience, we don't ask to code something or to solve some task on your laptop just right now. No, it's typically theoretical, to know some formulas, to know some frameworks, maybe some theory, how Atom works, what the complexity of the Atom of the optimizer, um, what the difference between Atom and the momentum method. So such something like this. But of course, it's the only example questions. So of course, we will focus on the large language model, retrieval information, some RL methods. So that's all.
And could you send us some kind of exam program? Because as far as I know, we were sent link for the lectures, but the topics there were slightly different than what we did in the seminars.
Mm. Seminars don't repeat the lectures, so that's why we have the another program, because here the seminars is something like about practice code something, etc. So that's why the different program on the lectures and the exam, that so because the lecture is something different like seminars, and this is why we don't ask you to code something, because seminars it's like the helping you to understand lectures and maybe to ask questions to me. So something like even in lectures, even in seminars. So if you don't understand something.
So the exam would be based on the topics from the lectures and not from the seminars.
Exactly. Yes.
Okay. And do you know about the homework? Like, how much weightage does the homework have in the overall grade?
Um, sometimes it's some, as you can see in our uh, today's seminar,
Yeah.
sometimes um, we don't have some capabilities to check all homeworks to the exam. That's strange situation, and but sometimes it depends. It's happens sometimes. So and I really hope that we will check all your homeworks in advance. before the exam, but I'm very sorry, but teachers, so they have their work too, and we have our exams too in PhD courses. So, and sometimes it's really hard to check all homeworks, but don't worry. Typically, if you don't have a mark about your homework, the teacher who you will who will ask you an exam, so he can see your notebook, your homeworks right at the exam, and just check it. So if he will have some questions to you, or it will be some misunderstandings mark for you, for example, just 9 or 7, yes, then for me, as for me, yes, so if I don't understand how can I mark the students, yes, so I will go to the form with all homeworks, and I will see the marks on the homework. If there are no mark, I just open the homework and see the code, your code, and your works, your yeah, so at home, so you're working a semester, and then if everything is okay, of course I will mark the 9. If you don't have the homework, or you just missed it, so then I marked 7. So this is like, it's typical situation. Don't worry about if you don't have a mark right in the exam date. It's okay. We solve all our problems. We know how we have what we have to do in such situations.
Okay, thank you.
Okay, so thank you so much for this seminar. Students, I really wish you good luck in your work, in your study, in your education. So thank you for semester 2. It was the great time together to learn something new. For me, it's like practice my English. I'm very sorry. So so that's all. That's all for today, and that's all for this semester. I really wish you good luck at the exams. Pass with flying colors.
Thank you. Have a nice day.
Goodbye.